All right, guys, we're going to get started.
Hello, everyone. My name is Amir Sharif. I'm VP of Product and Marketing here at Opsani, and I've had the good fortune to join the founding team that includes my colleague, Peter Nikolai. And Peter is the CTO. And in this conversation, Peter and I want to talk about cloud computing and the trends that we have witnessed. But before we get into that topic, I'd like for Peter to introduce himself and tell the world about it.
Hi, hi Amir, and first welcome to Opsani. We're really happy to have you join us. My name is Peter. I'm one of the co-founders and I'm CTO of the company. My passion has been in the last 20 years, infrastructure and making that infrastructure work better and with less effort, moving to autonomy. In the 2005-2006 time, I founded a company called 3Tera, which built the first cloud computing platform called AppLogic, where the emphasis was on converged infrastructure and declarative deployments. But the essence of it was that developers will be able to deploy and set the infrastructure as they need it, and be able to do it themselves.
So could you say that that was a forefather of cloud computing?
Definitely, yes.
So at 2005, then you were ahead of the curve. As you've seen cloud computing evolve from 3Tera, the form that you had, to what we are living in today.
That is correct. We called it utility computing initially, or data center operating system capabilities, but all the essence around it was what became cloud.
And now you decided to co-found Opsani, and because of the work that we do with continuous optimization, we see a lot of trends directly in cloud computing. I wonder if you want to reflect on what we saw together on AWS, because I certainly saw a few trends, and I'm curious about what you saw and the patterns that you detected over there.
Yes, that was actually quite interesting because I have been attending reInvent for the last 10 years, and in the beginning and until very recently, all the announcements that came out were all about new fundamental capabilities that now Amazon Web Services was able to do, enabling additional types of applications to be onboarded. So things like, in the early days, persistent storage, later on adding different locales, availability zones, all kind of principal computer as a service capabilities that gradually became sufficient to have pretty much any application running in the cloud. What we noticed when we were there, I think this is what you're referring to, is that when you look at the announcements that were made this year, the major things were all around improvements and additional services and extensions and manageability of applications that are already in the cloud. And I think that the main conclusion that comes out of this is that the migration to cloud has already happened. Most companies and most key applications are already running in the cloud. So Amazon is focusing no longer on enabling the migration to cloud. They now start focusing on improving the services, making it better, making it more manageable.
So largely, I can vouch on for this personally. My last startup, Apparetto, we had 0 servers. Everything was done in the cloud and various cloud service providers. So yes, that's a pattern that I saw as well, aside from my personal experience, that Amazon is assuming that you're already going to be operating in the cloud, and they're making it possible for you to digest more of their services for your application needs, which comes down to the cost vector of things. When startups were happening 10 years ago, 15 years ago, imagine 3Tera, you had lots of servers. Mm-hmm. And then we think about a company like Apparetto and had 0 servers. At Opsani here, we have 0 servers on premises.
Right.
Can you reflect on that and what that does to balance sheets?
Yes, so the main kind of move and the main driver for move to cloud at the business level, at a high kind of finance and large company, objective has been moving of capital expenditure or CapEx to OpEx. So instead of companies having data center on instead of large companies having their own data centers, building them out, buildings with cooling and power and buying computers and racking them and stacking them up, moving to operational expenditure, OpEx, which allows companies from small to very large to buy servers and compute infrastructure as they need it and pay for it on a monthly basis. So you don't make a one-time big investment, you don't have to amortize it over years, and you don't have to capacity plan as nearly as much as you had to do before. So if there was one major reason, financial and business reason for companies to move from on-premise data centers to cloud, the move from CapEx to OpEx was the thing that really sponsored that move.
So it used to be that I have this lump sum chunk of money that I would have to spend, and now I've gone to pay per use. I think, in fact, you were telling me that it's almost like your credit card is attached to an API, and your credit card is getting charged. But with that, and what I've witnessed in my company before was that there's a level of automation that comes with it. What do you think about the automation aspect of a cloud and how that enables enterprises to run more efficiently?
Yes, that is actually very important, because if we put the financial aspect aside, and again, by today, this is a kind of a trivial conclusion. CapEx to OpEx equals cloud, or cloud equals CapEx to OpEx. And that is a fundamental business driver that led cloud. However, there is another very important change, and that is one that I think I have a lot more visibility in through Twitter, and it is the move to fly-by-wire for computing. And
fly-by-wire, okay, and that's interesting.
Okay, so maybe I just can explain a little bit about what I mean by that. So this is an analogy with airplanes. Early airplanes had mechanical connections between the yoke, which is what the pilot moves to change the direction of the plane, to the wings and the tail surfaces that need to move. And those were long steel cables going through pulleys and complicated mechanical contraptions to make essentially the plane turn. And those were heavy, and they need a lot of maintenance. They need to be lubricated all the time, and they break. They are mechanical systems, and it's really hard to scale them for large airplanes because they also become very heavy. So companies that were building airplanes started moving to electronic control, which is called fly-by-wire, that allows pretty much the pilot to just have a joystick that pushes electrical contact. There's no mechanical linkage. Those signals go to a computer, and then the computer controls actuators at the wings and the tail. So the result is that the pilot can now make the same adjustments without any mechanical linkages. Now, just like in the cloud CapEx OpEx movement, there were a lot of basic and financial reasons to do that. One is cost. It's a lot cheaper to do it electronically. It's a lot lighter to do it. And it has become a lot more reliable. So these three reasons, all by themselves, which have been sufficient to move to fly-by-wire. Fundamentally, however, it also enables much more sophisticated autopilots to the degree to which we have autonomous flight. We have the ability to land automatically. So these things were not possible with previous mechanical contraptions. So, and this has already happened. All the big planes that we fly when we go somewhere, they all are fly-by-wire. So the same thing happened in cloud, and that is technologically fundamental change, not just business like CapEx, OpEx, but there is a fundamental technological change which enables fly-by-wire for compute and compute infrastructure. And kind of, again, going back to the old days when you had to buy computer or servers yourself and then rack them and stack them and connect monitors and keyboards and wire them to switches and install DVDs and CDs and configure BIOS settings and all that. Those days adding servers or removing servers was very expensive operation. Changing the ratio between CPU and memory was very, very hard to do. You have to open either byte chips, put them in, make sure they're the right ones, and so on. With cloud and what I call the cloud by wire capability of cloud, that all disappeared. All of these capabilities are now available through an API. And the result of this is not only is cheaper, and so we not only move from CapEx to OpEx, and I can get exactly as much as I need today, and tomorrow I may want to have something else. But what this enables is the beginning of autonomy in IT operations. Now that all of these capabilities are available through an API, we can start building computer and machine learning enabled systems that actually operate computer and infrastructure for us. And the obvious first implementation of this, and I think this is what you are alluding to, is the automated and horizontal autoscaling, which is as your application's needs grow, it automatically adds more instances to be able to handle more traffic. As the traffic goes down, it automatically removes these instances, so you end up paying less.
So one thing that you said right now, and I like the term, is cloud by wire. So let's talk about the cloud by wire. I have now gone into the cloud. I don't have the upfront payment penalty. My credit card is attached to an API, but so is my control level, and my applications can scale horizontally. Immediately, I see two sets of problems. The first problem comes from a personal example where I used to buy disk drives for various needs around the house. But now almost all my storage is done in the cloud. There's some local storage, but that's attached to devices, and I don't even worry about them. So my storage devices are effectively free, but I do pay a monthly fee to iCloud or to Google Drive or to whomever. And when I tally the cost for those over the years, I notice that I'm actually paying more than I need for storage for two reasons. One, I'm over-provisioned inside the cloud. Second, when I could have bought local storage, I'm assuming that I could have the same level of redundancy, that I can buy now 6 terabytes for $80. So it's much cheaper buying local storage. So that's the first of the problems. It's one of the over-provisioning. The second one is related to that in that, let's say that I have horizontal auto-scaling. The first unit that I auto-scale could be inherently inefficient. If I'm a developer, I'm going to size it so that it works, which means it's not efficient. It's more than enough. And so as the application then starts scaling horizontally, it becomes more and more efficient. The problem is that my credit card is attached to an API, and the cloud service provider is happily billing me for that inefficiency. Do you see the same perils?
This is absolutely happening in cloud infrastructure today. So both problems exist. As you have more infrastructure and you need more infrastructure, the complexity and the validation of the decision to add more infrastructure is very quick. This doesn't go through 3 levels of managers. Usually a developer or a manager or even an operator can add thousands of dollars per month in costs with just a push of a button or with a call on API. And in some cases, it can be automatically triggered by an autoscaler decision. But as you said, the most significant aspect of it is because of that fluidity and that those decisions that are made in the small and they're made on the spur of the moment, or in real time as it is with cloud infrastructure, as well as with your drives, the efficiency, there's no optimization, there's no thinking about, okay, do I need it? Is this the right unit of scale that I need? Imagine that for your drive, you are provisioning at a gigabyte at a time at certain cost. In some cases, depending on how you upload your pictures and music, this may not be the most efficient one to scale. You may be scaling too much ahead of time, but the unit of scale is not necessarily the right one. Kind of leaving the analogy aside and kind of going to what is really going on with applications, when you have a large application that usually is the one that auto-scales or has tens and hundreds or many cases thousands of instances, the importance of how much CPU, how much memory, how much disk and how much network each of these instances have, the autoscaling kind of hides the exact number. So autoscaling can take pretty much anything that the developer defines and just add enough. Just you put dollars into the credit card or in the API, and it just adds more instances. Is not straightforward. There are a lot of approaches that are based on looking at how much resources you're using on average utilization and so on that are actually really bad at helping you choose that size. So what we see, and we see this over and over, is developers pick whatever is easiest for them or whatever is sufficient to make sure that nothing bad is going to happen. So they just put as much as they can get away with. And then that ends up being the unit of scale. That ends up being how much is being built.
So that inherent inefficiency keeps propagating as the application scales up. The more successful your application is, the more unnecessary fees that you pay.
That is right.
And when we were walking around the show floor of AWS in Vegas in December, I noticed that there were effectively two primary types of cost protection mechanisms. One was around license management. The other one was around utilization monitoring. Do you think those two ways are sufficient for protecting companies against runaway OpEx?
No, they are not. I think they are necessary and useful, and naturally they emerged historically first, but there is more that is necessary. So I would define those as there's actually three different levels at which this can happen. And on the show floor, we saw all three. The first one was essentially license aggregation management resale. This is very similar to office space subleasing. I bought a building, I'm not using all of it, I'll sublease 2 floors or share them in some way. That's all that this is. This is the ability to essentially share or sublease excess capacity, whether it's license or whether it's infrastructure capacity. The second approach that you mentioned is the utilization base. So if you just open CloudWatch in Amazon, you will see, for example, that if on average your virtual machine has 40% CPU utilization. So that implies that you can go down to a smaller size which has half of the CPU and cost half the money. And that is how these systems work. And some of this is built-in Amazon capability. Amazon actually announced a service for compute optimization that does that. The problem with this is that this is based on average utilization, while performance is very frequently, the response times are based on peak and momentary load. So those are good for like forgotten VMs, something that somebody provisioned and forgot to take care of, or development level VMs which are not experiencing production loads. But we have seen over and over that for production loads, utilization-based resource changes don't work because they impact performance significantly and negatively and in an unpredictable way. The other issue with both types is that those are recommendations. So a system of either of the types would come to you and say, hey, you're using only that much. My recommendation is change and start using this or sublease these additional items. So you still have to take the action. You have to make that change. So in a way, if you kind of think from efficiency standpoint, this creates additional workload for your system administrators and for your operational teams. There is a third approach to this, and the main representative on the show floor there was Opsani, and that is the notion of continuous optimization. And what continuous optimization of resources is, it is the ability to control the amount of resources and actually all kinds of configuration, not just resource configuration, but do this based on performance metrics, things that are important to the business. So for, let's say, a SaaS company, the page load time response time is a key metric that defines customer satisfaction. Things like throughput and response times drive how much cost they will have to do. So taking into account both the performance metrics and the cost, and then optimizing the resources and the infrastructure configuration for the optimal configuration is what continuous optimization is. And the continuous part of it is doing this autonomously and doing this over and over. So we don't just do this once, you have to do this every time when your code gets released, or every time when a new package gets upgraded, or every time when something changes in the cloud.
So the continuous optimization, thank you for correcting me, it's the third way of doing this. Can you elaborate on how continuous optimization relates to autonomous operations, going back to the fly-by-wire example? And related back to the theme that we touched upon earlier is, how does it relate to OpEx reduction?
Okay, I will try to cover those in this order. So the first part is autonomy, and this is essential. Unlike the other approaches, which require humans, they make recommendations to humans, and then humans take action and make a judgment of whether this was good or not. Continuous optimization uses a closed loop operation. And what this means is that the machines make autonomous decisions to change the configuration. They evaluate the consequences and the impact of that, and either back out and try a different configuration, or if this is a better one, then they continue moving in that direction. There's a lot of ways to do it. We use machine learning, which allows us to do it very quickly and very efficiently in kind of business sense terms. But from the standpoint of autonomy is that this is done by machines and it is done 24/7. So how does this connect to the OpEx discussion we had? In a very important way. It ensures that the main optimization goal of continuous optimization is that it improves the efficiency, or it finds the optimal efficiency. So it makes sure that at the traffic level that you currently have, for the code that you currently have deployed, and on the cloud infrastructure that you're currently working with, your application is running in the most efficient configuration, or the optimal configuration, which means it meets the service level objectives for your application, something like, let's say, 50 milliseconds per page load at the lowest possible cost. And that changes over time. So as your team adds new features, you will need more resources. What continuous optimization ensures is that OpEx does not grow unchecked. It actually gets checked continuously on every release to make sure that it is the lowest possible amount that satisfies your business objective.
So, tracking your history, your career, starting out in cloud computing, where you are right now is allowing allowing autonomous operations to happen through continuous optimization. And what you're doing is giving the companies the best of both worlds. Become autonomous and control costs at the same time. Do I have that correct?
That is exactly correct.
And linking that back to what we saw at AWS, which is the assumption that you are in the cloud, that you're going to be running your application in the cloud, therefore all those services link back to the cloud. What Opsani now offers those customers is a way to control their costs and become more automated and more agile as businesses.
Yes, I believe this is the right technology at the right time. All companies, including large companies, have already migrated their most important applications to the cloud. So the footprint is there, the effort and load is there, and the continuous optimization technology to control OpEx is there as well.
Well, Peter, it's been a really interesting discussion. I'm glad that I've joined the team, and I'm glad to be working next to a cloud computing pioneer who continues to innovate that path. Thank you for having me along on this journey.
Thank you, Amir. It was really good talking with you.
So at this point, we'll begin taking questions from the audience.
please type your messages into the audience question form, and we'll give that a few seconds for it to come in. So the first question has come in. How is horizontal autoscaling different than continuous optimization? Peter, could you opine on that question?
Yes, we covered part of it, but those things work in slightly different mechanisms and achieve very different results. So horizontal autoscaling helps you adjust for load variations during the day, during the week, during the month. It's not an optimization per se. It just essentially, the more traffic you need to process, the more instances it adds, and vice versa. With lower traffic, instances are removed. This is a pretty straightforward control system that monitors one variable, which is the traffic, and controls one lever or one knob, which is how many instances you're using.
All right, thank you. Let's see if there are any other questions that are coming in. Okay, another question has come in. Would you ever have more than one type of optimization running for your company? For example, license and cost utilization, continuous optimization, and license aggregation. And I think this is related to part of the discussion where we're talking about subleasing and so forth, and you were talking about that.
That is actually an interesting question because they're independent mechanisms. I think some of them can be combined and they can be beneficially combined. So for example, the license aggregation or the savings plans, those things are things that you can always do and make sense. You just end up paying less for per resource. To a degree, doing the utilization approach and mixing it with continuous optimization is simply unnecessary. Continuous optimization does a better job at tuning the resources that are needed while maintaining performance.
Great. And another question has just come in. How is continuous optimization able to give both great performance and reduce cost greatly? So basically, how can you have your cake and eat it too?
Continuous optimization achieves what we call optimal efficiency. And efficiency is not something we really talk a lot about in software, but it is very well understood, I think easy to understand concept. It is the lowest cost per request or lowest cost per request per second. So then you can so that is what continuous optimization improves. And then the customer can take that improvement and allocate the improvement between performance and cost reduction. So you can say, I want to run just faster at the current cost. I can run at the same performance but pay a lot less. Or I can kind of balance this and say, I want some performance improvement and other part of that improvement to go to cost reduction.
Therefore, the customer has a choice. It's almost like a slider that can move between optimal performance, optimal cost, or a hybrid, whatever that your business needs.
Correct, and it is also a decision that can change over time. So, for example, toward the end of the quarter, the CFO may come and say, hey, we need to reduce cost by 20%. So you essentially move that slider down. As, let's say, in the next quarter, you have expectations of a significant growth and adding number of customers, you may want to increase performance.
Great, thank you. And I think we have time for one more question, and here it is. The question is, companies trade off CapEx to OpEx for scalability. And the question is, at which point in your scaling journey does it make sense or does this equation break down? Will you ever want to own your data center, I think, in another word, if you get big enough?
Yeah. I think you actually referred to that earlier in our conversation when you said, hey, I'm probably paying more for my online on-demand storage than if I just bought a few hard disks. So in a way, yes, that can happen, and many companies have experienced that as they have a sustained amount of resources where their needs don't change frequently, then it becomes cheaper for them to build their own data center. Now, cloud providers are actually handling this very well by providing discounts and ability to essentially do a volume purchase, which kind of moves it back to CapEx in terms of investment, in terms of financially how to deal with this. But you still don't have to build your own data center. The complex expertise of managing and building a data center still goes away. So I have seen some of the, let's say if you are willing to commit for 3 years for a number of instances, then you can get up to 70% discount, which brings it back into what you'll probably be paying if you're building your own data center.
So what I've noticed is that there are a few large companies that complain about runaway cloud costs. Then they learn how to optimize it and they bring the cost down. And what the trend that I'm seeing is unless you operate and lease your own cloud to other people, you generally want to use somebody else's infrastructure because the cost can be much lower because of that optimization.
Right. Well, the cost, I mean, the cost is kind of energy. You can reduce it in multiple ways. So one is by essentially moving this to OpEx or CapEx or buying in volume. But optimization is another approach to keeping the cost in check. So in all cases, you need both to be able to reduce.
All right, so unfortunately, that's all the time that we have, and I want to thank everyone out there for listening in. We will be back monthly with another webinar, and in the meanwhile, please come to our website, opsani.com, to get additional information. Thank you so much, and we look forward to seeing you online soon.